Okay, now what I want to teach you is mathematical induction, which is using formulas or patterns. So far in all our questions, we've had a sequence. So they've given us the actual numbers, the series itself, and it equals 2, so it looks like an equation. Now, some questions are going to provide a formula or a pattern instead of that. So let's have a look at what that would actually look like. We have this question which tells us, instead of showing us, it tells us a sequence is defined as the first term equals to 4, and the sequence follows a pattern of tn plus 1 equals to 3 times the initial term minus 2. Yeah? So this is just information. Now, it asks us to prove Tn equals to 3 to the power of n plus 1. Two things I want you to note. This is what we're proving, okay? So although there's extra formulas over there, it says prove this. So this is what we're proving. This is what we're focusing on. All this is just extra information that we're going to use to prove this over here, okay? So that's what I want you to think of it as. Now, as always, we need to start off with step 1, which is show it's true for n equals to 1. Now, we know it's n equals to 1 because it's told us here with t1 equals to 4. So we want to use that information. So we start off with the left-hand side, which is tn. Now, when t equals to 1, we're being told by the question it equals to 4. So we can just say the left-hand side equals to 4 because the question has told us so. Now, using the right-hand side of the equation, we have 3 to the power of 1 plus 1 equals to 4. So therefore, the left-hand side does equal to the right-hand side for n equals to 1. So just keep reminding yourself, this is what we're proving here. So let's move on to step 2, which is assuming it's true for n equals to k. So using this here, we're assuming that tk is equals to 3k plus 1, that this does indeed equal to that. We're making that assumption. Finally, in step 3, we want to show it's true for n equals to k plus 1. So substituting k plus 1 into n, we have tk plus 1 equals to 3 to the power of k plus 1 plus 1. So we want to show it's true for this, which means we want to show that the left-hand side equals to the right-hand side. And now we're going to start off with the left-hand side, which is tk plus 1, okay? So we have tk plus 1. Now is when we use the second part of the information, which is tn plus 1 equals to this. So by substituting in k, we can say that because this is given to us, so this is information that's given to us. So there's no proving necessary. We can use this information. So I'm using this information to say that tk plus 1 equals to 3 times tk minus 2. Can you see how I've used that information? And now is when I use the assumption, which is substituting tk for 3k plus 1. So I've just substituted this for this over here. And I can just expand that, and that's going to be 3 times 3k plus 3 minus 2, which equals to 3, that just equals to plus 1. Because you have 3 to the power of 1 times 3k, when you multiply them together, that's how you get k plus 1, which looks exactly like the right-hand side that we wanted to prove. So you can say that therefore, since we've proven the left-hand side does equal to the right-hand side, therefore it is true for n equals to k plus 1. And in conclusion, therefore, tn equals to 3n plus 1 is true for all integers of n is greater or equal to 1. Okay, so let's go through this again because it tends to confuse some students. So the first thing I want to say to you is don't be scared. If you see this and it looks unfamiliar, well, at least it looks familiar now and you'll know what to do. So remember, we're just proving this equation and this is information. And now, with step 3, what we're doing is using this information here to say that tk plus 1 equals to 3tk minus 2. And now we use the assumption. So usually what we're used to doing is having the equation there and using assumption. Whereas here, we have to use the information to make our equation first, essentially, and then we substitute in the assumption. and then the rest is just similar to what you've been doing before.